So gold is apparently on people's mind.
Gold is always on people's minds.
Yeah,
Always has been, always will be.
Yeah, I've done that, Ramon. It's recording.
there's very good reasons. I want to start with talking about the Chinese aspect. The Chinese have an interesting pair of words that have double meanings. One is the heart mind. So the same word for heart means mind. And it has four general swipes, which could be interpreted to also be the four gas giants and the tetragrammaton. So that's one interesting thing. The other one is gold. The word for gold means also metal, and the concept was that they believed that the iron left into the sun, or at least this is what the Sinologists have taken it to mean, that the iron left under the exposure of the sun will eventually turn gold. So they're talking about alchemy. So the question is, did the Chinese actually witness the formation of gold and so-called rivers of gold, filaments of gold, veins of gold from metals in the ground being struck by thunderbolts? And I would maintain that there's a lot of good evidence, but the main thing that can definitely be said is that if a supernova created gold, then as it exploded out, the gold atoms would spread out. They would not concentrate at all, let alone into rivulets inside of the earth and the ground. Also, the fact that gold tends to remain in very specific regions on the earth is a strong indicator that could not have come from explosions or have been gathered together from accretion, because the accretion would have been more spherical and lumpy, whereas gold comes in these rivers or in dust. And then my final point would be that the areas where the gold tends to be, we usually have strong evidence of electrogeology, except there's like no gold in Kentucky. And that's a very interesting thing. There is, however, a legend of silver. No one's found the silver since the legends, but the legend was that the silver was here. Could it have all been mined up? Don't know. But I would like to open up the discussion to talk about. I think that it's very obvious that that whole family, from copper down through platinum, everything that in that family is clearly just rearranging and packing in more density and improving the conductivity and decreasing the oxygenation, because copper is more oxidizable than silver and silver more than gold. Gold basically doesn't oxidize. Basically, it can over a long, 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 long period of time, but not really. And then platinum doesn't oxidize at all. So I'd like to open it up for people to talk about, what they think is happening and why mankind's obsessed with gold, and then I guess we could just move on from that point. So, Rick, you were saying about gold that mankind's obsessed with it.
Oh, you want me to go on?
Yeah, go ahead.
Well, I was just saying, gold has always been obsessed over by humanity. Um, since we have records, it's always been mentioned. It's always been sought after. It's the metal of the gods. It's their metal. The Anunnaki were said to have come here for gold. I don't believe it, but it is what it is. The tales are there, and the fixation of gold by humanity is a strange, very strange thing, in my view.
Yeah, it seems to have very few engineering applications, apart from being apparently a supercon. Is it a supercon? Well, it's a semiconductor. Probably a very good conductor.
It's an excellent conductor. That's all. It's not a
Yeah,
semiconductor.
yeah, yeah. but it seems to have been used so very not very many sort of engineering applications, but used an awful lot in sort of religious artifacts, certainly. Unless there are unknown uses of it that they were using in the pyramids, I'm sure. There's plenty of secrets that were.
Yeah.
And of course, it was always the target of alchemy, wasn't it, to produce gold? So it had this. It had also an ethereal sort of value as well. So that is a very interesting thing. I mean, turning base metals into gold was the goal, basically, and the allegory being throughout one's life, starting as an ignorant person and then discovering the gold of our own consciousness, I suppose.
Well, the fixation on gold might be that humanity witnessed all these other metals oxidizing, and nope, not gold. So that might be the initial fixation of humanity to gold, because it doesn't oxidize. Because when it's discovered, it's
I think
almost
that
like pure.
I think that you're missing a graver potentiality, which is that gold may not have existed prior to the explosion of Shamash and then the consequent thunderbolt activity. Because if most of Kentucky's formations appear to be more related to previous to the explosion of Shamash, with the exception of the Palladian Thunderbolt strike site, which is probably Jovian. Most of it seems to have been pre-Shamash during a time much more ancient, in which case then we're not talking direct arc discharge from Venus or Mars or the moon, but some other way that the electricity was utilized in order to create, say, the Lichtenberg knobs, in which case, if gold suddenly appeared and the mankind saw it, they would naturally associate. I mean, think of all the iconography with Olympus, even on Fortnite when they did the Olympus season a couple of seasons ago. Zeus is wearing gold and silver, but mostly gold is the iconography that we think of. We think of shining gods, golden.
I would submit that
glow.
I would submit that gold has always been here on the planet. Gold was created during the Z-pinch of the creation of the planet. I mean, if we're gonna go with the fact that gold might have been deposited here by Shamash as a supernova or mini nova, then that doesn't hold for me, because we know that
I said
thunderbolts create. Sorry, go ahead.
Current from the event. That's what I said. I didn't say that it was deposited by an exploding Shamash. I said since the explosion of Shamash, it could be that the gold was created through the filaments from all of the arc discharges that directly connected to the Earth and created the kimberlites. And that's
right.
What I'm saying.
The gold... I got you. I was confused. It happened so fast. I didn't know what was going on.
What I'm saying is that the gold might have been extremely rare before that, and always what could be gathered, used by the royal families. And then after the events, the Chinese and the Mayans and various people might have actually witnessed. Like, why is it that some of the New World cultures had so much gold in Mexico? And we know that Mexico is a site of really strong electrogeological evidence. That people might have chosen to live there because it had been struck by thunderbolts and so much gold was left, and this was a sign of the gods. And so what I'm saying is the iconography of the gods seems to be associated with gold. Whether or not it has to do with the Anunnakis who need to farm it for their atmosphere is irrelevant. That's my point. Robert showed up here.
Ramon, could I put a little bit in on that? So
when we look at gold, you also have to look at in the southern hemisphere in Australia. Well, in the 1850s, they just found it lying on the ground. It meant nothing to the natives. You go to some of the American countries that are American countries now, it meant nothing to them either. It was just laying around on the ground. It would seem that somewhere along the line, yes, its ability to be shone up and polished and all that and utilised. And then eventually, of course, it was turned into a form of money because it was looked at that no one else can reproduce it. And I hear people talking now we should go to a gold standard. And I just suggested if we did go back to a gold standard within 20 years, there would be anywhere where it's possible to be gold, there would not be a tree or anything left on the ground because it would all be dug up for the gold because the person who's got the gold becomes a wealthy person. I get confused that why do we get fascinated with it? What does it actually give us? You know, we've got all these vaults of gold, but how does it help humanity? You know, other than if you used it in electrical appliances. You know, really, what's its purpose? Anyway.
My view on the issue with gold is that it did not tarnish, it doesn't rust. And that alone would have made it valuable for a variety of reasons.
Not only valuable, magical.
Yeah, magical, but the other thing is that the other metals they were using, like iron and tin, silver and the rest of them, copper even, they all suffer rust processes. So they don't
Oxidization, yep.
They don't remain pure metal. Although you can find deposits of pure silver that isn't tarnished. They're very rare. And the deposit of silver found by the Athenians, you know, made them an empire because they used that money to build their triremes. So the real issue is that gold was something that could be used as a medium of exchange, and was seen ornamental as well as economic in value. But in terms of where did the gold come from, where do the minerals of the upper crust come from? The legends we have of the periodic depositions from Saturn onto the Earth in terms of floodwaters and dirt and all the rest of it, oil, I think the majority of the Earth's surface minerals did come about through that process. And given that electricity will produce nuclear fusion processes, it's not just that we got metals and all the rest of it. We also get deposits of uranium and other heavier elements that are being produced with the energy discharges that were occurring. So the kimberlite process, myself and Roy have been talking about this stuff, and I keep claiming that a thunderbolt from the sky can penetrate very deep into the earth and in the process produce kimberlite and the diamonds and everything that else that goes with these sorts of things. And in more recent times, we're finding electrical discharges in the Golan Heights has been producing minerals through electrical activity on the surface of the planet. So the geological explanation of where things come from in the mainstream, I don't think is anywhere near close to the right story. The sources of where minerals can come from has also caused serious debate between myself and Roy, because he's a full-on mineralologist, and I'm saying to create a high pressure, high density mineral, all you need is the environment. You don't need to be under the earth and covered by 10 billion tons of pressure and temperature. If you've got a plasma effect occurring, you will create a high pressure mineral, and it'll just fall out of the sky wherever it does. if it's coming to the Earth. And we have legends of, you know, periods of darkness, Ragnarok, the Vikings talk about the winter and all the rest of it. Those sorts of things can be produced by a solar mass ejection or mini nova or whatever you want to call the damn thing. By the time that material arrives at the Earth, not only has it undergone cooling and electrical processes, it will also have undergone mineralization processes due to the high temperature plasma environment conditions that give rise to these ejections. To claim that these minerals are formed deep down and under high pressure is ignoring the fact that the sun can produce the exact environment required, and this stuff can just fall out of the sky. And when we've got Saturn, we're orbiting Saturn as a planet, according to our legends, and under those circumstances, as Saturn turns back from a star to a planet, it's releasing huge amounts of energy, and that the energy quantity there is more than sufficient to produce the outcomes of fusion of heavier elements that just simply fall on the ground. The Earth gets lots of surface minerals. So where this stuff comes from, you know, it's everywhere, basically.
Well, we're not sure how gold gets created, but I think it could be a combination of high energy and low energy nuclear reactions.
Well, I proposed a model, a synthesis model for for element creation. That all that's required is you get two given atoms, like you get two oxygen atoms, you join them together. So oxygen is 8. You double it up, you get 16. And if you need to go further along the line, it's just a case of doubling up what you get. But the important thing is we need to apply the SAM, the structured atomic model, to create the geometry of the nucleus that's stable. So you might have 2 oxygens and a couple of hydrogens to produce a stable geometry in the nucleus. When that was first suggested to the group that Roy's involved with, they poo-hooed the idea and did some experiments and then went, "You could be right." So they haven't published that information. So it's clear from the Sapphire project, the way that the species of elements that were created were indicative of this, you know, get 2 atoms of the same type, join them together and create a heavier atom using electricity. And it's absorbing energy, but the amount of energy being processed is quite dramatic. And what a lot of people ignore, especially in the mainstream, is that above our heads in our own ionosphere, we're getting the creation of uranium and a whole bunch of other elements that are thought to be produced in stars. And if you treat Earth as a star because it's got an active magnetic field and geometric ionic field, it's expressing a net energy. More energy is being released than is being absorbed from the sun. It's behaving as a low-power star. And I suspect that every planet that has the sort of conditions of an active a magnetosphere and electrical discharges and all the rest of it, that you'll get the sort of results that are conductive of producing heavier elements. You don't need a nova event. You don't need the sort of stuff that mainstream claims are being made about how metals get created or how heavier elements are produced. So the simple fact is I don't think we really understand what the proper processes are, and mainstream science does not want to accept the evidence that's coming out of the lab. And I suspect that Los Alamos labs and a few other places like that have been able to create whatever element they want on demand as much as they want. And I don't think that the periodic table ends at 118. I've been told, we need to have the names for another 300 elements. Whether that's true or not, I don't know. I don't have categoric proof of it, but there's no reason why we can't have element 450 sitting out there in the environment, just waiting to be detected, and it will be very heavy. So we're seeing papers in some of the more recent papers talking about these very heavy elements with this theoretical island of stability in the geometry of the atom. It tells me that mainstream science don't know what they're talking about the majority of the time. They don't. They lack the imagination to understand what's possible. And then they lack the imagination to produce the sort of experiments that'll prove it right or wrong one way or the other. And then you add into that, we've got to keep this a military secret because it's creating an element that might be really useful for whatever reason, like occurred with Lazar's exposure of element 115 back in the 80s. So there's a variety of people that just will not accept the truth, and they're prepared to lie about it just to keep whatever fantasy of we're important going. Anyway, that's where I'm standing.
So, Ramon, getting back to the originality of gold, as I understand it also, quartz and gold go together. And out where I live, from memory, if you find a quartz seam running north-south, that's where you'll look for your gold. And majority of times there'll be somewhere along it. Yeah, but it is amazing how when you find it, it shows all the signs of being very hot, and something smashed it and spread it. So, yeah, that's the other thing when you see what they call nuggets. They all look like they've had a lot of heat, so they've been fairly soft, and then something cooled them quick, smashed them, and then they just sort of dispersed like that. So, yeah, anyway, someone else can have a chat.
Well, they always said you'll find a pot of gold at the end of the rainbow. So it does suggest that there is some kind of a atmospheric interaction with the ground that produces these veins, because they come out in veins as well. Yeah, nuggets, they do. Now, things of a similar temperature. I can't remember if they attract or repel. And also things that are radiant. I'm not sure how it works where liquids kind of flocculate. I think that whatever the gold, I think it was probably, like you say, Robert, a fusion of two previous elements. I can't imagine what that would be at the moment, but I don't know what half the atomic weight of gold that element is.
I'm just going to open up one of my documents. It's got a periodic table in it. I'll answer the question shortly.
But yeah, I think, and also the Martin Fleischmann report, he's reporting this sort of doubling of the atomic sizes in his experiments, where he's producing these elements out of other elements, not notably copper and steel, and then he's producing silicon, oxygen, all sorts of other things in his experiments. Low energy. Well, no, these are high energy ones. I'm thinking about it. But yeah, there's an awful lot they don't know, and he's discovering quite a lot as we speak. about this type of transformation. So yeah, the formation of gold, it seems to have something to do with energetic systems. It seems to, like you said, follow along these particular lines. Is it something to do with the currents, geo-electric currents? I think they're meant to exist. People believe they exist. You know, and I think we are. But I think there is a soliton in the middle of the Earth, and it's probably generating all sorts of metals, which are, for one reason or another, finding their own layer. According to their well, as in the Birkeland currents, you know, the different elements are put on their own shell, aren't they, on their own ring? So maybe that process happens in the Earth as well, to an extent. So yeah, that's about all I know about gold.
Now, I was just thinking there, Nick, and Rob might be able to pick up on some of this. So in Australia, we have a couple of locations, because it's a fairly big landmass. So we have a couple of locations where, and now they can track it seismically very well. So we have an area in Victoria that basically, if you want to go down, well, there's a lot being dug out of it now. If you want to go down far enough, you virtually dig it out like it's in a vault. And then that sort of runs veins, and where those veins sort of finished, there was really good copper mines going back years ago. Then I remember one night we're on Google Earth and Rob was poking around with, around that Western Australia, Northern Territory area. And of course, in Western Australia and that, there's also huge amounts of gold, but you can follow it along lines. And at the end of those lines, there's also often copper. So maybe copper and gold do have a link. Anyway, I'll let you get to what you're going to talk about, Rob.
Well, with copper, you always find zinc and lead along with it, and a smattering of gold. But going back to gold, which is element number 47, if I halve 47, I get 22, and 22 is titanium, I think it is, Ti. But it's an odd number, so.
Sorry, really Robert. Gold is AU79.
Sorry. Okay. So I'm looking at silver. Sorry. Halving gold, it's effectively element 40. You know, if I get two element 40s and add them together, which is zirconium. But if I halve that again, I can go down to element 20, which is calcium. So I could get 4 atoms of calcium, put them together and spit out a hydrogen atom or a neutron and get gold directly. So in those circumstances, the sort of synthesis chain is very, very different to what we would normally think. So two nitrogen atoms would produce a silicon atom. If I double up the silicon atom, I'll get to element number 28, which is nickel. And if I double up nickel again, I get to element 56, which is barium. It is Ba. So the issue here is that when we're talking nuclear synthesis, we're talking about geometric stability of the nucleus that results. And that's going to require a balanced sort of arrangement. And the SAM model provides a way of growing elements based upon specific platonic shapes, which are joined together and produce a stable arrangement in terms of geometry, with one of the nucleoids already part of the existing structure. But it's not the same thing as the nuclear synthesis model that comes out of the hydrogen bomb experiments that they did. Now, they produced a synthesis model based upon radioactive outcomes. So there are different processes that produce nuclear synthesis. There's a biological one that's low energy, where you turn sodium into potassium and things like that, which is an endothermic reaction. And human beings do that in hot weather. They eat salt and produce potassium. Then you've got the chickens who are able to produce calcium from their environment directly, by eating the ground effectively. Plants do the same sort of thing. They will create the necessary elements for photosynthesis and other things directly from the source material. Oxygen and hydrogen, of course, are critical to these sorts of things. But if I get a bunch of atoms and I need carbon, then maybe I can reverse that synthesis process. I can break down a heavier element into a lighter element. And so when I look at what's called chemistry, I just see it as it's a nuclear process go to woe. The idea of separating molecular compounds, that process to create water, for example, is no different to synthesizing helium. It's just a different process. The only major change is the amount of energy and what catalysts are needed to get those reactions to happen. So all these reactions are in fact nuclear, and creating a compound like water requires the formation of a neutron to create the bond, and that is a nuclear process. But it's all based upon electrics, because the way you make these molecular compounds work is valence, and that is electrical charge. And magnetic charge is also going to have a role in this process that chemistry tends to ignore. The orientation of electrical and magnetic fields are critical to the geometry of what's being produced. So, why does carbon produce hexagonal rings, and why do boron compounds produce hexagonal rings, and why does water produce hexagonal rings? And there's got to be a reason for this behavior, and I don't think physics or chemistry or nuclear chemistry of any kind have even come close to understanding what's going on. And it's riddled with this assumption stuff that's occurred for the last 250 years. We have an assumption that's never questioned, never tested, never criticized, and as a consequence, the ability to explain behavior is neutered. I've said in the past that Ampere's assumption that a moving electric charge produces a magnetic field is false. And the reason why I can say that is that the behavior of the photon wouldn't be what we've observed if Ampere's assumption held up, because the minute the electric field goes to zero, there should be no magnetic field, and therefore the photon shouldn't go through this cyclic process of a zero state to a maximum positive to a zero to a maximum negative and so on. That behavior would not occur if Ampere's assumption was correct. So the electricity and magnetism have to be separately explained, however, because of the geometry of construction, occur. I'm having problems with my software. But anyway, so mainstream science really has dropped the ball, and it's never come back and investigated are the assumptions that were made by people who didn't even understand what made up the wire or whatever in the past, that we've since discovered the structure of the atom and all the rest of it. It's never come back and explained these features, and it seems to want to avoid having to explain any of the features. I learned it at university. They gave me a pass mark because I answered the question the way they wanted to, but that doesn't mean that the answer was right. And I really hate the words theory and law and all the rest of it in terms of physics, because all we really have is stuff that appears to be correct, yet to be proven false, and that's not a good enough test for saying that it's the way it will always happen. That's just not the case. And then you've got the issues with symmetry, and the assumptive explanations that come out of cosmology and quantum theory, that is just quantum speculation, that is just unfounded. I was given an explanation that there was some event that was seen at the edge of the solar system. There was a flash, and the immediate response of one of the persons involved in seeing this result was, "Oh, that's proof that there's dark matter." Well, it doesn't prove anything. All it proves is you saw a flash. You got no idea why that flash occurred. And then you've got the arguments about the black hole stuff. That's the mathematics has been proven to be false for Einstein's relativity stuff. The Hilbert solution to creating a black hole is mathematically flawed. It's actually errored. Schwarzkopf's speculations have not produced the claimed result according to the modern day cosmologists. And nobody is prepared to accept the fact that the mathematics that is used to justify these behaviors has in fact been proven wrong. And we see, oh, relativity has been proved because we've got GPS systems and all the rest of it. Well, the GPS system was built ignoring relativity. It wasn't required. Yet everybody seems to have to produce, oh, here's concrete proof that relativity is true, and we've got concrete proof that the entire theory is wrong. And I put this to someone who claims to know something about it. He claimed to have read all 4,000 papers that Einstein ever wrote, and I didn't think that Einstein had written that many papers. But anyway, if he has, then well and good. But that doesn't prove that Einstein got it right. And when you've got someone who's sat down and spent the hours doing the mathematics that proves it wrong, the immediate result, the minute I mentioned Carruthers' name to this guy, he just said, oh, he's a upset person who's a lunatic, because he challenged the academic system that disallowed him from pursuing his PhD. And I'm thinking, well, the simple fact is the universities did an injustice. They should be taken to court and done over. But that's not going to happen because the courts don't think they've got the authority to tell the academics that you've got to prove what you say. And, the courtroom is a bunch of lawyers who don't understand physics at all. So this is the issue we're dealing with. We've got all these people that have, their income and their status is all based upon lies. It's a sandcastle. It's getting corroded by the ocean, and they refuse to accept the fact that they need to change their castle. They need to relocate. They need to change their basis. And I don't know how you deal with it. Ivor Cat, who was, I don't know whether he's still around, but he'd be in 98 by now, basically said that I should be put in charge of the universities. And I said I'd need the River Styx to flush out the rubbish. I'd have to sack everybody. And there's no way knowing that that's going to happen. And besides that, why would I want to waste my time dealing with people who will not listen, who will not justify what they say with evidence? They're quite prepared to take the taxpayer money and waste it in the case of CERN and places like that, LIGO, but they're not prepared to put their own hand in their own pocket and take out their own money and prove what they claim to be the case is the case with repeatable, verified experiment. You know, theoretical physics is just that, it's theoretical. It's not backed up by any sort of experiment that means anything. Redshift can be explained by a whole variety of informations other than expanding space. And the problem with the explanation, if space is not expanding, then the explanation of redshift by modern cosmology ceases to exist. And to his deathbed, Hubble did not come down on what the cause of the redshift was. He was in a quandary as to whether it was expanding space or absorption and re-emission of energy. So, and they just refuse. There are experiments that show that redshift can be achieved by means other than what they're claiming. And it's just become, you know, we do science by press release without having to produce any evidence of what we're claiming is true. And I think there are two reasons for this to occur. One is we have military technology that is no longer secret if the truth about what's really going on in physics comes out, and they're being paid to lie. They're just being paid to lie because their reputation fails if they have to provide an explanation that really does the job that it's supposed to do. So, and as evidence of that sort of behavior, just look at the mobile phone. The biggest environmental change since 1975 is the introduction of the mobile phone that emits energy in the RF frequencies that affect magnetic navigation of animals. It burns out their brains. So if we're talking insects and bees in particular, if you burn out their navigation, their magnetic navigation, they can't return to the hive starves and the bees disappear. And there have been papers that have produced the evidence to show that this actually occurs. And the first thing that the telecommunications companies do is they go and buy their prostitute science guy who writes a report that says, oh, it's everything except. It's pesticides, it's environmental change, climate change, whatever is possible, so long as you remove the possibility of the mobile phone being the direct change. But if you look at what's happened to populations of animals that depend upon insects, they've all crashed. And they've crashed year on year since 1975 when the mobile phone was first released. And that technology was put into the environment without any EPA study at all about what its detrimental impacts are on living systems. And we know that RF frequency will interfere with biological systems and that will damage them. You know, if you wear your phone in your top left pocket of your shirt, you can kiss your heart goodbye because the phone will cook your heart and that will kill you. But oh no, it can't be the phone that does that. So why do we have all this stuff that says don't use your mobile phone within half a metre of your head or your body if it doesn't cause this sort of stuff to happen? And oh, by the way, the mobile phone is transmitting in the microwave frequencies that we use to cook food. And how do we cook food? We boil water. What's the body what's the major consistency in the human body? Water. So if we submit the water in the body to microwave energies, we will cook our body. And there are people that have literally fried themselves in a microwave environment. You know, dead bodies found around microwaves, military guys that, you know, go out there and they were going to sun on the rooftop, and somebody switches on the microwave system, and they come back the next morning and discover the guy's been cooked. You know, the claims that we have in science are just so abjectly wrong that the people who make those claims should be thrown out of their jobs and put in a jail cell as a reward. And climate change, the single largest object impacting the Earth at the moment is the sun. Yes, human beings can cause problems with pollution, but nothing compared to the sun. We're talking orders of magnitude of energy that are, you know, 1% variance in sun output is going to cook the planet Earth. It's that much energy being whacked into the system. So the claims that are being made are not reasonable. And the truth is, they don't want to tell the truth. They just don't want to do it, because that means they have to admit that they're idiots and that they were wrong and that they should give their money back. But they're never going to do that.
Well, that's all exciting, but we've heard that rant before. Let's move forward.
Yeah,
here.
but when we're trying to work out where did the minerals of the planet Earth come from that are on the surface,
yeah.
if we apply the standard geology theory, how does the stuff that's supposed to have sunk to the core of the planet suddenly able to reappear on the surface through kilometers of rock? How do you get it from the mantle to the surface? How do you get it from the core to the surface?
Well, Rob, on that question, I can't tell you about the core, but I can say this. So between Denali and Wedderburn, that place has been flogged for gold nuggets. Like, I mean, it gets detectors over it all the time, right? Yet there continually appears to surface nuggets of gold. Now, one of the things that I was told years ago was it's to do with the roots of trees that bring it up. Right now, it could be off of that connection with trees. But I've noticed even in my own paddocks, you'll have them without a rock on the surface, and every now and then you'll go in there, and next minute there's these bloody quartz rocks sitting on the surface of the ground. Well, where do they come from? You get what I mean? They've got to have come up. There's no sign like they've been given birth. They're just all of a sudden sitting there. But if you ran a mower over them, you'd know you hit them.
There's a hydrological process that will certainly transport gold and other minerals from below up. So water will move it. Water will dissolve gold and move it. Bacteria will do the same thing. Quartz, you know, again, is something that you've got corrosion of the surface soil and the exposure of rock and all the rest of it. But you've also got, you know, it falls out of the sky, quite literally, onto the ground. I made a prediction about meteorites. One of the things that occurs is when we have a meteorite coming through the atmosphere, it develops an ionized layer around it. Well, that's electromagnetic structure. And if the conditions are correct, a huge chunk of rock, say 10 kilometers in diameter, could literally just plop on the surface of the Earth, causing no more than a just, you know, dump sound. No, not even a seismic shock of any kind, because when this rock comes into the atmosphere, it gets surrounded by ionosphere structure that interacts with the Earth's magnetic field, and the velocity of the fall is arrested, and it just plops on the ground, and there it is, just sitting there. when what you should have is, a crater the size of Chicxulub or, or Gauze's Bluff or some other place where we got an impact. So I made the comment that, the way an asteroid or a meteorite could land upon the Earth is a various. You could have an impact like a bullet. You could have it obliterate itself because of internal electrical and magnetic stress, or it could just simply plop on the ground because its velocity is arrested by the environment itself. And when I made that prediction, I got the normal response from Roy that, that can't happen. And then it went to the team in the United States and they went, well, actually it can. It's been observed. And I'm thinking, how many times am I going to make these sorts of statements and find out that it has been observed? And the trouble is that given that it's been observed, why wasn't the paper allowed to be published? Why was the simple fact that if a meteorite just simply plops itself on the ground without without a bang or anything, that clearly is going to upset geology and cosmology big time, because it needs an explanation and they don't have one. We know these events occur and we can't just ignore them. I think birds themselves must generate an electromagnetic field structure around their bodies that literally propels them away from the surface of the Earth to a capacitance layer of potentiality where it's easy to fly.
Yeah, that makes a bit of sense. That they need a bit of help. Yes.
Right.
Yes.
Fish, for example, Schwarberger said that, the fish, the salmon in the stream, he did experiments on this. If it was cold water, the fish was literally pushed by the water forward. But if you put hot water in the stream, they had to struggle to keep their position in the stream. They had to actually use muscles to go against the flow of water. And then you have the salmon clearing 15-meter jumps where there is no water to go from, up over the waterfall up to a higher level. How do they, what's the conditions that enable them to swim air 15 meters up into a higher water level, into the pool of water above where they start? And this is stuff he observed, and the professors in the academic institutions didn't like the fact that he said that this is what occurs. They hadn't observed it. They didn't want to believe that this person who didn't have their quality of qualifications was outdoing them. He built the sluice system that deforested Austria effectively. He was able to have a discussion face to face with Hitler and say that all his scientists need to be fired, and got away with it. It's amazing stuff. The simple fact is that this guy understood the necessity of observing nature and then applying the lessons that you observe. Figure out why the salmon just sit there as the water's pushing them forward. They're not swimming, they're just sitting there. Why should they just sit there? Why does the water flow past them, enabling them to remain on station?
Now, I did read that and see the result for that, but I can't remember it. There is a reason for that, because there is something, if you stir the water up not far from the fish then has to move to keep its position. Yes. But if the water's just running naturally, well, then the way the fish is and it sits there, the water sort of parts around it, and that would be
the fluid flow against their body forces their body to move against the fluid flow. It's that simple.
Yeah.
But it's like Eric Lathwaite was shown this pendulum process that enabled a a machine or wheeled device that had this pendulum moving enabled it to appear like it was an infinite energy. It was just rolling forward and nobody could explain it. But they go to the mathematician and says, oh yeah, we've known about this for hundreds of years. It's, you know, here's the mathematics behind it, and laid it all out and explained why this thing behaved the way it did. But the majority of people in science, even Lathwaite, you know, hadn't done the maths, didn't understand that this phenomenon could be explained. It was a big shock to everybody. It was like the lecture he did on gyroscopes that proved that he could make something lighter by spinning it. And that, you know, the physics, the people who claim to be knowledgeable about physics should understand all those processes because they've been documented hundreds of years ago. They're just ignorant. They really are. They're amazingly ignorant. And I've seen people make statements of saying, oh, if it's not been peer reviewed, then it's not real. And if that's the case, well, peer review only began in the mid-70s. 1975 or thereabouts. So everything prior to that should be thrown out because it hasn't been peer reviewed. So let's just go and get Maxwell's equations, drop them in the black hole of forget, and all the rest of it. All that electrodynamic stuff is clearly crap because it hasn't been peer reviewed, according to this person who reckoned that everything should be peer reviewed. You know, the guy who made that statement should have his academic qualifications revoked. Because he's an ignorant.
I think it's relevant.
Snot.
I think it's relevant that, and considering the sun spins round every 11 Earth days, the sun rotates, which is an awfully fast bloody rotation.
28 days. The sunspots take 28 days.
28 days to go around the sun, yeah.
But that's only. All that 28 days, it says how fast the photosphere is rotating. It doesn't tell you how fast the actual whatever is underneath the photosphere rotates. It's the same with Jupiter.
My point being that its speed of rotation is bloody fast in miles per hour, and if you're on a point of the equator, around the equator, you're rotating bloody fast.
Yeah. It's
How
miles across.
How significantly would that affect, that gyroscopic effect, the mass of that particular system? I presume it'd reduce it quite a lot.
Well, it's electron. If it's rotating quickly, the electrons are going to go to the outside, and the protons are going to go to the inside, which is what, because the electrons are light, they'll move. But where does the nuclear fusion process of the sun actually happen? It's in that place that's 20 million degrees, how many kilometres, 2 solar radii from the bloody surface of the sun is where the nuclear fusion occurs. Which is why when we look at
what I'm trying to establish is the mass of the sun, the calculations correct? Would there be different gyroscopic effects on the Earth and planets?
Well, there would have to be. Rotation changes the apparent weight of everything.
Yeah,
That's the reason why. It's the reason why we have gyroscopes in jet fighters, is to make them aerodynamically stable. And the gyroscopes are set to the place where they're spun up. They're that specific. So if I spin up a gyroscope where I am and you spin up a gyroscope where you are, and we put these two things together, their angles and everything will be different. So there's a lot of stuff that is explained mathematically in physics that the vast majority of people who achieve a physics degree, and let's just say undergraduate, forget about the guys that are coming on later, do not ever cover in their coursework. So it's hardly a surprise that people get a PhD that get a much more narrow focus of learning, have got no idea what they're talking about. Roy is always talking about this. There's a program in Australia which was a quiz program, and it was a hard quiz program. And there's this guy who he just completed his astronomy PhD, and he was asked a whole series of questions about astronomy, and he could not answer a single question and get it right. Couldn't do it. Constellations, stars, all this. He was asked those sorts of questions and he couldn't answer them. So what's the value of his PhD in astronomy if you can't answer basic astronomy questions? And this is the issue with science. It's that restricted in stupidity and status that the actual basic learning has just been missed. I was looking at some of the papers to get into university doing the mathematics courses in famous US universities in the 1800s. And I was looking at the mathematical questions you had to get answers to. You had to sit there, exam and pass. And I'm thinking, sugar. I struggled to answer some of the questions, but I would suggest that I would have been lucky to get a 50% pass mark. I wouldn't have made the entrance into the university, that's for sure. And I'm thinking, if the modern PhD claimants and master's degrees and even just undergraduate degrees, I would say the majority of the people who would get, if they were given those papers to answer, would not pass them. They're that decrepit in their skill. And with the introduction of calculators, which for me was 1978, I did my senior year matric. I was allowed to use a slide rule. The year before, you had to use log tables. The year after, you were allowed to use calculators. So that's 1977 for me. And ever since then, I would say that as far as the ability to do mental arithmetic has just vanished. And that's the year I put for Australia. Australia got turned dumb in mathematics in school. It might have occurred earlier in other countries or later, but the calculator itself has just made the vast majority of people stupid in maths. And then with the introduction of the internet in the 1990s, with Google search and all the rest of it, the sort of knowledge you would have had to learn from books and memorize directly, it's just vanished. So people who are doing university courses since mid-1990s are dumb, just straight up dumb. The people who came before them had to go to the library, had to read, had to study, because there wasn't an internet search engine. You couldn't just go and find all this stuff at the click of a button. And today, they never learn it. So it's hardly a surprise that the vast majority of papers written today, I'd be surprised if any of the reviewers read the paper that's presented, let alone go to the reference papers and check to see whether they stick together or whether the reference papers exist. The sort of thoroughness that used to occur prior to peer review has just disappeared. So it's not done. And everybody just assumes that whatever's being presented is correct, which is why we get 650 papers being put into peer-reviewed journals and getting published as fact, and then later on being proved to be total crap made up just to test whether peer review was being done properly, much to the embarrassment of all the science journals that suffered the treatment for it. But, this is what we're dealing with dumbification of science.
Well, you see, Rob, you got to go now into the modern thing, like you just said, 650 papers. And at what point does it become overload? So you just keep having these things getting churned out. At what point do people start turning off, even in that communities? Because it just becomes overload, and then something that shouldn't be missed is missed, and the opposite way around. And, like I was listening to a bloke today having a crack at a politician over his, questioning of the chief scientist and that on climate change. And it was quite interesting, this bloke's having a crack at the politician. And, the scientists would be right and all this. But as you said earlier, and that's a really good point, we may be contributing to climate change, but the biggest contributor to the Earth's climate, of course, is the sun and the other planets. We all know that as well, but this wasn't mentioned. And this seems to be with a lot of these. You know, I'll go back to Nick put up a video, gee, it'd be 18 months ago, about the priest. Well, what was the name of them, Nick? Can you remember? They were Irish, and they were considered to know everything, and he was the last one left or something. And he said, in the world today, it's impossible for everybody for someone to consider they could know everything. You remember that, Nick?
Yeah, the last of the Druids.
Yeah. Yeah.
Yeah.
But the trouble is,
totally,
I think Nick
I mean, they
very...
memorised things, didn't they? They memorised things.
Yeah.
They could memorise massive lists of things. They had incredible memory as well, and recall for facts, numbers. So yeah.
Yeah, so when you look at it, Nick, Rob, today, like you say with those people doing PhDs, well, there's just too much really for one person. But the trouble is, if you went down this side of it, I went down that side of it, instead of us at the end sitting down and working out a comparison and groups doing that, it's now all come down to prestige and money, where I want my way the only way because I need the prestige and the money, or you do. And so then it becomes this so-called competitive thing instead of where it should be encouraged to be, yes, be competitive, but also put it together so that it's not only the competitive side, but it's also the side of working together and putting things together. But, you know, like I say, it's winner takes all in today's world. And I think that's one of the big problems.
That's always been the case. If you look at the Millikan oil drop experiment, you know, there was a competition between NRAFT and Millikan about what the actual charge, the Coulomb charge of an electron or the electrical thing. But in those experiments, at the time they were done, the idea that the proton existed, they knew that there was a positive charge structure somewhere, but which was produced by the anode tubes, but nobody knew what they were. And the idea that there was something other than an electron wasn't really well founded. The idea that there was antimatter, there was a paper written in 1898 that actually postulated negative opposite charge structure and opposite structure itself. You know, an opposite charge structure and an anti-structure, which is what I call antimatter. The opposite charge structure is not antimatter. Those things were postulated in 1898 in a serious scientific project. So it's 12 years later, or 10 years later, he starts his oil drop experiment to determine the charge of an electron, which of course had been discovered in 1892, which was what, nearly 20 years earlier. And so when Millikan did his experiments, the idea that the electron could have a charge other than negative, I don't think he even knew about. If he'd read that paper, I'd be surprised that he knew of the paper, because I'm fairly sure it was done in Germany at the time. NRAFT might have known about it. You've had it, and Millikan was, you know, all about fame and fortune, because whoever came up with the value of the electric charge for an electron, you're in line for the Nobel Prize in physics and fame and fortune, pretty much. So there was a strong competitive reason for doing it. There's been a controversy running ever since. And then about 2 years ago, a Chinese paper has been produced showing, confirming NRAF's fractal charge arrangements, and the guy who's coming out of this in China is making the claim that the electric charge of an electron can be varied directly. And I have no problems with that idea, because the electron is a construction, a circuit that is absorbing and emitting A ether. And the A ether is what is the basis of the electric charge value itself. The scalar value of the electric charge and the magnetic charge of an electron is directly impacted by how much A ether structure is in the electron. And if the electron can express and absorb that material, then the charge of the electron has to change. It's impossible to come up with another solution. And what we know is the electron, it has structure, yet mainstream physics says it's a lepton, it cannot be varied, it can't be changed. And we've got papers that are showing that it can be changed. We've got people who, I know of 3 examples where the claim that I've made about electrons and protons in terms of the scalar value of the charges have to be fundamentally different, have confirmed that they are fundamentally different. The people who did those experiments were still coming from the instant coffee university answer to that. What is in the textbook is the positive charge is just minus the electric charge. And that was never true. And it was never proven. It's never been proven by Millikan or by NRAF because they never measured the electric charge of a proton. Because protons don't just evaporate from an oil drop. You need a chemical change to get the hydrogen atom to emit, to get the nucleus. So the experiment's never been done till very recently. And the people who have been doing these experiments are confirming that the proton charge value scalar is completely different to the electric negative scalar value. And we have 3 different electrical charge values in terms of statistical analysis because we've got 3 different types of electrons. We've got 3 different types of protons. And as a result, we've got, you know, a heap of different arrangements for neutrons because you've got 3 electrons to choose from, you've got 3 protons to choose from, you've got their anti-charge variants and their antimatter variants. You can create a huge quantity of neutrons just from the fact that there are 9 types of electron and 9 types of proton, and you need a bunch of photons to make the thing stable. So, which explains why the neutrons have different half-lives. It's just almost like, you know, understanding the basics and then explaining them with a reasonable theory that's not based upon Harry Potter magic in terms of quantum stuff is just amazing. The proton or the neutron is made up of 3 quarks. The weight of the quarks is heavier than the resultant structure, the proton structure or the neutron structure. How the hell can the resulting structure be lighter than the inputs? We just lost a couple of guys. Bad to go. So yeah.
Yeah, we're probably getting around that sort of wrap up time. Yeah.
So, you know, it's like.
So I can hear him typing, can't I?
Sorry?
Ramon's still around. I can hear him typing, can't I?
I can only see myself, you, and Nicholas.
Yeah, I'm here, yeah.
So, but anyway, you know, the real issue here is when we talk about where do the minerals on the surface of the Earth come from, I can't see a process which gets them from the core and lifts them all the way to the surface in the quantities we observe. We know that the mantle has plumes in it. It's like when you boil water, there'll be a lava lamp is probably a better example. You heat up the material, it rises and then it falls and it rises and it falls. That happens in the mantle. It's beyond dispute. However, between the mantle and the crust is this material that's incredibly hard. You know, they've drilled down to it and they can't cut it. So unless you can fracture it and allow the mantle to ooze out all over the surface like occurred in the Siberian traps or Dakan traps, that is a mechanism to get it to the surface and it would work. So Iceland, you would expect that Iceland's seeing these material from deep down being exuded out of the mantle onto the surface of the Earth. But I don't know what the mineralogy of Iceland is. You know, they're finding lots of gold and silver and whatever else that's supposed to be down deep coming up. Is that being expressed in those volcanic eruptions that are occurring there? The same sort of thing would occur in the Rift Valley in Ethiopia, where you've got these fractures occurring as well. So along the plate boundaries, I would expect magma to ooze out, but it doesn't ooze out in the sort of quantities that would justify the surface deposition of minerals that we use in our modern environment. The mining industry goes and collects. Whereas if they come from a dying star, chucking out material that's being transmuted on the way to the surface, and it just literally rains onto the top of the Earth, that would be a better explanation of where these minerals come from. Certainly in the case of oil and carbohydrate, the hydrate material, the carbon hydrocarbon deposits in California. The American Indian legends of that region describes river of fire that then get buried. So, you know, where does the oil come from? Is it percolates from the earth below, or does it rain, or did it rain from above? I think there are multiple processes that can occur that would explain the oil deposits. It's just that we don't know enough about them and about what could happen and what does happen. And that's what we see with assumptionitis. You know, Ampere didn't know the details. He made an assumption, and now it's, you know, the law. That he made that as the observation in ignorance of what was actually there. And I'm wondering what Ampere would claim today if he knew that detail. What would he revise his assumption? Hans Alfman, for example, with his model of plasma, said, don't use my plasma my explanation of the plasma that I used to say, don't use it because it's invalid. But the science people wouldn't listen. They wanted to continue using the old system because, you know, whatever reason, they weren't listening. They won't listen. And as Walt Thornhill said, to unlearn something is incredibly hard.
On that note, I want to point out that it is almost impossible to find Alphen's actual speech. References to it are everywhere, but and they mention it on the Nobel site, but actually getting a copy is conspicuously difficult to do. And that's probably not an accident. It's probably related to the topic of which he spoke of. However, I haven't gone looking for other Nobel Prize speeches from that era to see if it's unusual that it's missing. I'm just saying it is a little conspicuous that such a controversial speech is not provided in full and referenced anywhere that I could find. It probably is somewhere in some library, but I just can't. I haven't been able to find it.
Well, that's one thing. There's a Bell's Labs experiment in 1939. They did a report on redshift, and in 2015 I was able to find that paper, but I haven't been able to find it since. It's been removed. So there's a deliberate effort to censor science, to get rid of papers in the past, and you see this in stuff that the American military got interested in around the time of the Second World War and since. Before there were lots of papers like Townsend Brown and others produced a whole heap of papers, and then suddenly it all shut down about the time of the Second World War, and it's remained invisible ever since. So the question is, why? The only answer is that there must be military technology that requires that information, and in order to keep ahead of the game, you don't publish the basic science to keep it all hidden. And in fact, you publish stuff that's rubbish to enable the other guys to waste their time trying to figure this out. And I suspect a lot of that has occurred, which would explain why a lot of Tesla's papers and others have just never seen the light of day. It's that important in terms of currently available military technology. It gives an advantage to one side, which is both worrying and interesting in terms of what's going on. But I suspect that, you know, if the basic science had been well understood by the Soviet Union or the Chinese communists, what the military environment would look like today, and if the US military was that far in front, they've shown remarkable restraint in terms of the way they've gone about trying to keep the world at peace. But, you know, it's only a matter of time before some psychopath gets in charge and you've got a bigger problem happening. But the thing that I find interesting is you're getting countries like China and Iran, a few other places that are redoing the basic physics and coming up with solutions that we wouldn't expect those countries to be producing. Like Iran's got the hypersonic missiles that the Americans have had since the mid-70s, if not earlier. The Russians, you know, supposedly only just got the technology, but I reckon they've had it for a while. They've just only published it now because they're getting fed up.
I just came across that was all.
So, yeah.
Yeah, one like yours.
So,
yeah,
if there's secret military technology based upon a different understanding in the physics, keeping it all silent and hidden would make a lot of sense. But the problem is...
the problem with keeping it, Rob, the problem with that theory of keeping it all hidden and all that is, that's all right why the group that were involved in putting it together are all a group. But as they get older, splinter off, you have new ones come in and all that. Gradually, the reasoning behind it changes, and then does it still become such a thing that no one else can know about it, or does it start then seeping and leaking? And, you know, I often think when we look around, we hear different ones talking about different things. Gee, I still don't know that we're that far advanced of where a lot of others are that we can take the risk, if you know what I mean. I tend to think, watching what's been going on, especially the last 12, 18 months, we're pretty good at destroying each other, but I still think in a really total outburst. And it comes down to what Keating said a while back, and I think this applies to the US the same. Except for someone throwing missiles at you, it's virtually impossible for them to land on a modern coastline like, say, Australia or the US. You know, if China wanted to invade the US, they'd have a lot of difficulty getting across and landing on the shores. With missiles, now Europe's a different kettle of fish, as we see, with what's going on there. You know, so I often think, you know, a lot of this that they give the military's possibly sitting on a lot of things that I don't even think they understand. And they're sitting on them because, eh?
For sure.
You know, I think there's, you know, if they don't understand them, they're sitting on them, and you could argue that they're preventing humanity from going ahead.
Well, that's part of the issue.
That's one of the big reasons why we're in this lock barrel about what part of climate we impact on, our soils, our food networks, is because there's too many things that are probably locked up because someone at a higher level doesn't understand it, but doesn't want it to be understood because it might upset the current structures.
Well,
And that's real that. And they don't have an alternative for them.
Well, they don't have a transition mechanism that's going to work without creating massive dislocation. Like I'm sure that there are vehicles out there that exist that do not require fuel. And if that's the case, what is the transition mechanism of the economy to replace vehicles that require fuel with vehicles that don't require fuel? And then you've got the strategic issues of the fact that there are assholes on the planet that will use that technology to attack others. And the transition of the economy is incredible. I mean, look at the impact of the internal combustion engine had in the world, in terms of it removed horses from the environment and those sorts of transport systems, the steam engines and all the rest of it. You know, if we were to transition to another solution, you are going to throw a large portion of the economy completely out. It's gone for good. If we had the ability to produce, I wrote a story that talked about the replicator machine being applied just to food itself. Imagine you got the Star Trek replicator solution. You can literally produce whatever meal you liked, whenever you wished, however you wished, wherever. Right? All you needed was an electrical input in this machine. The impact on the economy of such a machine being available to everybody. Well, first of all, the farmers can kiss their income goodbye. There's no justification to have a farm in the first place. There's no justification to have a transport in this infrastructure to move food around the place. All the supermarkets and all that sort of stuff disappear. Food manufacturers no longer required. That sort of a change to the economy is just chaos. You're going to cause social chaos because a whole bunch of people are going to lose income and the capacity to buy anything.
Well, this is what I'm getting at, Rob. Is we know that from the past, and we know from the past that each time we've had these big changes, we've actually caused some really big crashes in our systems, which have really failed a lot of people, right? Resets, total resets. Yeah. Now, the thing is, if we know that there's been things that are probably not good to continue to use for various reasons, but if I'm earning my living from them, like I remember when they first started getting rid of asbestos, people walking around, it's all bullshit. And that was because they were scared of where this would lead them because they earn income from that system. And really that comes down to we have to build economies that will allow you to transition. And Nick, I think you'll agree that the Mystify science one that we've listened to a couple of times, they've got a new one out and it might be worth having a listen to too, because it's basically talking about those things whereby, you know, the discussion of about a lot of those things that we actually get into, Nick.
Yeah, I've missed the last couple of them, but yeah, they're normally pretty thought-provoking. Normally, those pretty good. Yeah. Well worth seeing who they've got.
Well, the latest one. I've got it up now. So they sit down for discussion about the futility of rationalism by way of William James' varieties of religious experience. We start with a question of utopias and try to diagnose why, if they're doomed to fail, is it still worth trying to create them? And then move on to the question of the scientific project, which seems to be an attempt to create a rationalist utopia.
Well, I don't think you
Yeah,
can
I
create
can't
a
imagine.
utopia.
I don't know what differentiates a rationalist from anyone else, really.
I just
But,
don't think the idea that you can have a utopia is you can have a dystopia. That's not a problem, but a utopia is going to eliminate the desire of self-improvement. You know, you look at our at the
Well,
development.
yes and no. I'll give you yes and a no to that.
Yeah, but the thing is, it's a desire to achieve more than your peers that drives some of the development and the economy that we have. But the economy we have is based upon stealing the wealth created by people to give it to people who don't require the wealth. You know,
Yes.
and so that's been true for ever since Queen Elizabeth I gave the Bank of England its charter to be a bank, and the banking system has, if you look through the history since its establishment, the banking system has caused a major economic failure every 30 to 60, every 30 years, every 30 years until 19, till 28, and then they've put in a management system that stopped it from crashing until 87 when they had the financial crisis, and ever since we've had a whole series of financial crises ever since. Major crashes, the banks themselves have gone, wiped out. And the fundamental issue with the banking system is that the transactional value exchange system needs to be completely divorced from the lending system. In other words, the service, the organizations that provide the transaction value transfer should not be allowed ever to lend money to anybody. The system, the money that's in this transactional system is owned by the people who use it. It's not owned by the system. But there's this attitude inside the financial sector that if our company has the custody of that money, it's ours, and it's not. It's not theirs. And the people who are in charge of it are people, psychopaths whose whole goal is to have lots of money, and they don't care whose it is, just as long as they have control of it.
But the system's set up that they can actually default and not have to pay. In other words, they can legally steal. All right. But anyway, let's go back to this here. What this podcast will be about. So then it seems to suggest that there is something about the tremendous experience of being alive that will leave us with the feeling of being part of something larger than ourselves, no matter how rational we get. So then if we can never escape the mystical experience, is it worth trying? And if it is, and we take the project of science to be worthwhile, where does the mystic live? So that'll be interesting one to listen to, I think, Nick.
Physics.
Yeah, I think so, yeah.
Physics has to explain why there is life. It has to explain why there's love and hate, because that's the natural environment. When we're talking about physics, we're talking about natural philosophy, where the job of physics is to explain the natural environment we find ourselves in. And if we're going to say love and hate and good and bad is not part of physics, then physics is derailed. Physics came out of religious spiritualism in the first place. And there's nothing to say that religious spiritualism didn't come out of scientific endeavor of the past. All you have to do is look around at the guys that are looking at the current science and turning it into a religion. It's exactly what's happening. You got the people who don't understand it, the people who think they have an answer of the nature that we're criticizing reasonably. They're turning it into a religion. Terence Howard he doesn't understand the real, he's got a misunderstanding in what he thinks is going on. He's trying to turn it into a religion, or you're trying to create a cult type statement that says, oh, the sun can micronova, so we've got to prepare ourselves against that event and all the rest of it. the way we've set up the electrical grid, if it was the house generated its own power,
The
Carrington
audience
event.
doesn't miss that. That's a swipe at Ben Davidson because he's setting up a cult because of the micronova.
Well, he's not the
Just
only
so
one
that
who's doing it. He's not the only one doing it. All I'm saying
yeah,
is
well, I
that
want to make sure we point it out.
Yeah,
First of all,
okay,
I'm on
yeah.
I'm on my man cycle, and secondly, all these pricks need to be called out. Just saying.
But if you're
Before
using
the show,
fear,
go over
my
own
issue
stuff.
is if you're using fear to promote an agenda, then you don't deserve to be heard. Which is one of the
Yeah, I
reasons
agree
why I
with
wasn't going to mention his name. But
Yeah,
but
well,
what we're seeing is there are people who are prepared to use science, even programs like ourselves where we talk about the aether and all the rest of it, and the fact that the universe is alive and all the rest of it. There are people out there turning it into a religion because, you know, we think that this is actual science. But they don't want to put the effort into learning, you know, and investigating to see whether our perspective holds up. You know, they just want to believe it. You know, they've been given an answer. It's like the guys who go to university. They're being given an answer for whatever problem's been presented, and they don't have to think about it anymore. They just apply the formula and it's done. This is the problem we have. University is supposed to churn out people who can think. But I think all that we've got is people being churned out who've been given, you know, the magic wand of whatever to fix known problems. And in terms of figuring out what to do about the unknown problems, is just, well, here's hoping that we don't blow ourselves up. It's not the right way. And yeah.
Morrison defunded philosophy
So,
in Australia.
you know, in philosophy.
Did you know that, Rob?
What?
Yeah. The philosophy side of most of our universities has virtually disappeared because it was defunded.
Oh, it's obliterated. It's obliterated. Like the idea
Right.
that you would
So
do
you're
an
never going
arts
to look
degree.
into the future.
The arts degree, for example. I mean, I went to university in the early '80s, right? If you looked at, you know, what were the degrees that got you fame and fortune and status? The answer was you did law, you did medicine, you did technology-based stuff like chemistry or physics or biology, not so much, but computing, yeah. They were the status degrees. The ones that were, you know, oh, you must be too dumb to go to university, were arts, humanities, teaching, right? And all those degrees, you know, just languages was another one. You just chucked them away. You just never did them because they weren't important. Philosophy, of course, was at the bottom of the you know, only the people that were really esoteric or nerds, as it were, did philosophy. But the guys who did philosophy used to go and get the pamphlets at one of the universities I went to. They'd sit down and they'd literally pull apart the pamphlet and expose the bullshit in the pamphlet and publish it. And nobody was very happy about the fact that the philosophy guys were doing that to their paper. But, you know, it's the sort of stuff that you need. You need. Not everybody in the world can be a doctor. Because if everybody was a doctor, who's going to grow our food? Who's going to fix our car? Who's going to program our computer? All the rest of that sort of stuff. Not everybody can be a doctor, and not everybody wants to be a doctor. But we've got a political system that says you've got to go to university to get a well-paid job. Why? Steve Jobs went to university, dropped out, and what's he now? Dead, apart from dead, but he was incredibly rich while he was alive. Same with Bill Gates and a few of the others. You know, that you don't need university to get rich. The rich employ people who come from university, but you've got to wonder whether there's any value in doing that. So, but yeah, it's a bit strange.
Anyway.
So I'm not saying a university education's invaluable, and I'm not saying that, you know, doing a trades qualification's invaluable. It's just that we need a mix of everything. And there are better ways of doing it. But the first thing we've got to do in our society is get rid of the people who think that because they are the ones that are set up a business or whatever are the deserving of all the wealth. You know, the reason why they're wealthy in the first place is a group of people agreed with them and created that wealth that they reckon they own.
Well, Well, Rob, we'll see how honest Bill goes when he takes over Vice Chancellor in Canberra.
Who's this?
Bill Shorten.
Vice Chancellor, yeah. I good luck to him. University of Canberra was where I happened to actually get my degree from, but yeah, it was seen as it was a TAFE college type stuff. You know, it wasn't a real university until later in the piece, because it, you know, ANU was the status one, and University of Canberra was, you know, the technology university. But you know, we're seeing changes, but Bill Shorten as the Vice Chancellor, well, he's not the Chancellor, so his impact is going to be interesting.
But he's still going to earn a lot more money than he does as a politician.
Yeah, well.
Robert, before I get off, and as much fun as it is to listen to your rhetoric, I posted a abstract yesterday that the AI had written off of a very theoretical thought experiment. But it's based on actual empirical known things. I'd like you to take a look at it. If you want to read it out loud, that's up to you.
Which one's is that in
all about ether? It's all about ether. Yeah, it's in the chat. It's not very far back.
I've been trying to reset my biological clock, and I've had some success. So on the weekend, hopefully, I'll get back to a normal sleeping pattern. But
I thought it'd be nice to get your reaction on the show.
Yeah, I'll have a look at it. I'll have a look at it. But there's only one issue I'm thinking that I wanted to bring up here tonight was the prediction that half the jobs of the world that exist today are going to disappear because of automation via AI. And
no, that's an outrageous number. It's not true. It's not going to be half.
Well, it can't be half. It might be half.
It's going to be about three quarters are going to be totally affected by it, and it's going to be something that's on job interviews, just like Microsoft Word or something. But it's, you know,
but I suspect it's more.
They're not even remotely something that AI can do. Not even remotely.
The sort of things that I think AI could take over and displace humans from administrative tasks in government agencies and businesses, and even in
another thing is if the AI could take your job wasn't worth anything to begin with. And you are overpaid in the very first point.
Well, you know, I started my career, and within 5 years, the government agency I worked for lost half the employees because the computer did their job. Completely.
Right. Well, try opening the PDF and at least give it a skim through.
I'll go through it and have a look and see what's there. So it's
It's an ether. It's about ether and charges and in the air, etc. Has come to my mind the audience background while you're looking at it there. They give the audience a background. I was thinking about when I tell people in the clinic that ether is 100th the part of air. It's very thin, you know, and of course I'm being metaphorical there. No one knows exactly what part of air ether would be. It could be a 1-to-1 ratio. It could be a 1 in 20 trillion. We don't really know, but so I came up with a method that I wanted the AI to experimentally go through, and it did a really good job. A couple of times it invented some ratios that I didn't ask for, but then it went down the avenue.
So what was its ratio?
It particularly was using the Debbia length to create the distances between the free charges available in air. And then I used a standard cycle of chi, which is about 20 minutes of breathing, and I used centimeters cubed to keep things standardized, and tried to I want to donate to your church.
Thank you so much. We appreciate it. That's the sponsors on the front there that help sponsor the car wash for us.
Well, thank you.
Thank you. Have a good day.
God bless.
God bless you. Thank you.
And I think that kid just whacked his shin on my trailer hitch. Yeah, that would not be fun. And to use the Debbia length to try and figure out how many charges are around there, and then also create a theoretical cubic cubic inch of charge with reasonable density, not an unreasonable, perfect cube of ether, but what would it take to actually accumulate that cube? It took a surprising number of breaths, honestly. It was well over the billions, and it was like millions of years in order to breathe that much ether. So I thought that was very interesting. And then it started doing comparisons as to what the value is versus, say, the ATP chemical reactions in the body and calories that you wouldn't really be running on the free floating charge if the sea of charge is used as a model for the ether. So it's anyways, an interesting thought experiment. My goal is to get away from the phi math for our pursuit of an ether. I think that the problem of theoretical physics and of philosophy is most likely that we've not been very inventive about how to discover the ether. We've just kind of gone, well, it's like a child who can't find something. I can't find it, Dad. And I just go open the drawer, there it is. I think that physics has said it's easier to just go Michelson-Morley and then be like, oh, it doesn't exist, rather than actually take a look at everything that's reacting. I do know that there have been calculations done. There's a lot of variance of argument about the vacuum energy and the 0 point. So that version of the ether, or that part of the ether, because there's really three main parts, right? There's the process part where things are converting. There's the energy source part, which is some kind of vacuum energy or 0 point, and then there's the various seas of charge, baryons, etc., that are factually findable. But then the question still becomes, like, where does the charge itself get its energy? So there's a continual search, and I do think it is sort of a triquetra that all three are true about the ether, and yet how do we actually mathematically define that? And using philosophical math for it is only so good, because in the end, while somebody probably will be crazy enough one day in the next 1,000 years to build a machine based on the philosophical math, most investors are not going to pay for the engineering to, off the basis of philosophical math alone. So I thought of one new empirical method to discuss it, which is respiration. However, there are so many guesses and estimations that are being used, and the AI is doing its best to actually do that. And of course, then the math itself has to be checked, because the AI is famously a little bad. Hopefully, if it's working that quickly, it probably contacted Wolfram to actually do the math in the background, but it doesn't really tell you. It just does the math and calculates everything. But I thought it was a very interesting exercise, nonetheless.
So is this PMD research PDF that's?
I don't know anything about PMD.
You've got a GPT chat PEMD.
Yeah. Oh yeah, the PEM dynamics. Oh, PEMD. Yeah, PEM dynamics. So
that's the
I
paper
use
I need to read.
the PEM dynamics.
The
first,
comment I got.
I didn't the entire background. I started by asking the PEM Dynamics bot what its thoughts on ether were, and it gave really satisfactory results. And talked about some historical examples, and it talked about Decenti, and it talked about some useful stuff. And I was like, okay, good. So it's keyed in. Then I briefly talked with it about, I asked its opinion about, now that we're finding, interference when we turn the interferometers vertical, what do you think about that? And gave some. So all in all, it was actually like 26 pages. I only took the last 2 pages, and I did a little bit more today. But that's all afterthought.
I'll take a look at it, but the stuff that my thinking on the aether is that there's scale levels, and I can't verify what the claims have been made from Roy via his sources, but we're talking if we were to look at an aethic structure, we're talking about 10 to the minus 1,024 meters in terms of scale.
Yeah, even smaller than the K curvature. I remember you.
And it's probably way smaller than that. So the aether, the thing that's at the aether struck this, the basis seed particle of the aether must produce is it has a simplex geometry. In other words, triangles, tetrahedrons, and the simplex. That's the geometry of the structure. It needs a flow mechanism that vibrates. So it has a geometry, it has a flow, and it has a charge mechanism. So what we're coming to at the moment in our discussions with Roy and myself is that there is some sort of frequency mechanism of flow that produces a characteristics that we might call electricity or magnetism or something else. And these things are basic charges that will express. But these things, because electromagnetics is involved, and they can produce a virtual mechanism, a virtual charge behavior, which is what we see in temperature and things. But fundamental to this is this idea of opposites. So you've got a dipole structure or polarity structure that you talk about, which is a dipole arrangement of two charge extremes that have a neutral position between them. So it produces a tri-state environment. So we got a binary mechanism that's producing a trinary mechanism, but the fundamental geometry of this structure is tetrahedral or simplex.
Yeah, I would tend to agree with that because that's the simplest non-spherical.
And the reason why I come to triangle is if we get the nodes of a tetrahedron in a fully mapped, the tetrahedron will map three-dimensional space without any waste of space. It's a tessellating structure. But the nodes of the tetrahedron produce the geometrical structure for the cube, the octahedron, the icecahedron, the dodecahedron. All the platonic solids come out of that, a simplex node structure. So these things are interrelated in that sense. The one that's a bit weird is the teapot, which is the donut structure, and which will turn cups and things like that. But the important thing to understand in the geometry that I think is going on is that when I get a simplex structure and I physically turn it inside out through an inversion process, so the outside becomes the inside type mechanism, is that the structure you get is an ovoid, a donut type structure. It's not a sphere, it's an ovoid. And that, what's happening is that this aethic structure flips between a simplex structure and this ovoid structure. It just oscillates between the two. And between those, you get these structures can be incredibly small and self-contained. And when we're talking about Tesla's explanation of, what if we wanted to understand what the basic structures, he was talking about fields, vibration, and flow, which is a similar sort of thing. But how you get a structure that is not solid creating what we think is a solid is quite a bit of a leap for the majority of people out there. The atom is not a solid structure. The neutron is not a solid structure. The electron's not solid. The proton's not solid. The photon itself is not solid. But we tend to think of these things as being little beads, round spheroid structures, but they're not. They're mostly empty space, all the way down to a structure that it's like when you got a ceiling fan, you switch it on and it'll rotate, but you can't put your hand between the blades. The blades will stop your hand from going through them. Well, it's the same thing with this structure. It's a loop of field of flow that's spinning so fast that when you try to pass the spinning structure and get to the inside, you're blocked by the fact that it's rotating too quickly and you just bounce off it. This is the sort of thing that you get what looks like a solid from something that isn't. But yeah, I'm still trying to work out how you can get this geometry and physical behavior to occur to express, you know, electrics or magnetics or temperature or you know, alive, ethics, good, evil, you know, all this sort of stuff. It has to be built fundamentally into whatever is the building block of the universe. That it has to be existing in there, because if it isn't existing in there, then the fractal geometry that creates the universe wouldn't have good or evil, love or hate, or any of that stuff. It wouldn't exist. So it has to be in the structure itself, which is one of the reasons why I'm saying the universe, the physical universe in its basic configuration, has to be a living organism of some kind. And it's our understanding of what alive actually means is a bit of a problem, because our scale is what our problem is. We just do not have the ability to imagine or visualize or sense the actual environment in which we live. And it's very hard to pin it down, because some people can sense things a bit better than others. You know, some people can see ultraviolet light, others can't. You know, it's that sort of arrangement, and those that can't don't believe that anybody else is right because it's not part of their personal experience.
That's correct, Rob. Yes.
Us being the witness is not a good enough justification for our views. But anyway, so yeah.
Anyway, that's been pretty good. So what do you reckon, Ramon? We wrap this one up. Hi, Nick. Hello.
Yeah, I think that more or less I've said the things that I came to say today. So it's about time for me to focus on these kids. It's 11 in the morning here. So I feel done. I feel spent. I think most people have had their say. Is there anything else, Nick, that you wanted to cover?
No, Nick's not answering at the moment. Anyway, we'll all stop the record.
All right.